Hey, thanks. I know that I've only got about 10 minutes to kind of go through this. Is there any way for there, I got it. One of the things is that what I was involved with is LeadScope under Glenn Myatt had a NIEHS grant to try and develop in silico toxicology protocols. And they started off with genetic toxicology, published a paper on that, also did one on skin sensitization. And then they put together this special issue of computational toxicology, which on the right includes a fair number of different articles, of which one of the ones that I was involved with was called Trying to Develop an In Silico Protocol for Carcinogenicity. And that's what I'll first mention. So if you go to the next slide. One of the things we were talking about is actually developing a protocol, but we ended up with more of a position paper as we started getting into it. This involves some 70 different scientists over 40 different organizations. This is the paper that was published in 2021 after about 2 years of consideration. And what led us to do this was to try and look at the 10 characteristics of carcinogens and try and see what in silico approaches were available for those particular KCs. And if you go to the next slide. So there are several things that we ended up doing as we went through and looked at each individual key characteristic and looked to see to what extent there were in silico computational models that could be used for predicting that particular downstream effect. But one of the things that we decided to do is to try and put this, and this is a work in progress. This is our first try at trying to put together a model of the interactions between the KCs and the 3 stages of carcinogenesis. One of the things to point out is that each of the KCs is color-coded. And if you look in the upper right, it says known human carcinogens group 1, and the extent to which a different KC was involved in those particular carcinogen are noted. This is from a paper that was done by Krusky et al., published in 2019, where out of 86, if I remember correctly, 86 chemical carcinogens, 85 of them had positive gene tox data. So that's the one that shows the deepest red, and the one with the lowest amount of data was KC8, which is modulate receptor mediated effects. So this is an interaction between multiple KCs and how they might have common modes of action somewhere down the line, and then as they relate to tumor initiation, tumor promotion, and tumor progression. Again, this is a work in progress. It's not definitive, but it was to try and get our mind around how these things might interact. Next slide, please. So there were some general conclusions. One of them, there's a lack of global computational methods, except for is genotoxic. For some of the KCs, assays did exist that could be used to provide robust data for developing computational methods, but not for most of them. And it's largely part because they're not required for submitting data for regulatory purposes. So those assays were not used in a kind of like a global format kind of way. And then the other thing we wanted to bring to everybody's attention is, given that many of the KCs interact with each other, it is unclear to us how much information is sufficient and how the data should be combined to generate an overall assessment along with an associated level of confidence. Clearly, some of them, if you look at genotoxicity as an example, might be sufficient in and of itself, as was mentioned earlier. But other ones, we don't know what they actually mean in terms of carcinogenicity. So we published this paper, but then the next slide, please. We decided that what we would do is put together a working group to look at potential case studies where we try and incorporate in silico data along with experimental data, including both in vitro and in vivo. We've kind of put together a set of teams looking at different compounds. These are just case studies to try and see, to the extent that the mechanistic data might be informative, or the 10 KCs might be informative, to the extent that data exists. So you can read this. We have a non-genotoxic and carcinogenic pregabalin, which induces tumors in mice. We have acetaminophen, we have lasiocarpine, and we're trying to put a group together to look at quinacrine, which is a mutagenic drug widely used to prevent malaria during World War II, and actually is also used as an anti-fertility drug as far as that goes. Next slide, please. Need to go to slide number 6, please. So one of the things that we also decided to do is that recently the FDA has started coming out with an addendum to guidelines on testing for carcinogenicity in pharmaceuticals, the S1B. And one of the things they talked about doing is introducing a weight of evidence approach to assess the human carcinogenic potential of small molecule pharmaceuticals in order to determine whether a 2-year rat carcinogenicity study would add value. If something would be clearly thought to be a carcinogen in humans, you don't need to do a rat study. If something was clearly determined not to be a carcinogen in humans, you don't need to do a 2-year rat study. You would still have to do a mouse studies, but this would give rise to an effort that might be able to reduce the amount of animal usage for that particular purpose. So one of the things that we wanted to do is to take a look at how we might apply the 10 key characteristics to the weight of evidence approach that's being put forth by the FDA and this particular group. Next slide, please. So this is across the top is the weight of evidence approach. It's broken down into 6 different categories. Number 1 is data that informs the carcinogenic potential based on drug target biology, knowing pharmacological mechanisms. Second one is secondary pharmacology. Third one is histopath. 4 is hormonal perturbations. 5th is genetic toxicology. 6th is immune modulation. So on the left-hand side is all the 10 key characteristics. We do have X's populating other ones, but I'm just showing the ones that we're a little bit more sure of right now. So clearly genetic toxicology would have a series of X's in them. Same thing with immune modulation or receptor-mediated effects, epigenetics. But a lot of the other ones, we're still trying to figure out how to do that. So this is a working group that just started about 2 or 3 months ago. And it's just getting ready to try and start doing these integration. Next slide, please. So this is where we are. We are really, let's see, very strongly respectful and appreciative of the 10 key characteristics and how they might allow us to start looking at other ways of predicting carcinogenicity. And in terms developing computational methods that could be used to help in that particular effort. And then we started working on case studies, and then we're starting to do this integration of the 10 key characteristics with the weight of evidence for the ICH S1B addendum. So if anybody out there is interested in participating in any of these things, please give me a ring on my email, and I'll make sure that I hook you in with the right people. Again, my congratulations to Martin for all the efforts that he's done, but I don't expect him to just fall into a hole and disappear. I think he'll still be around for many years, providing his own particular insights into the work that we do. Thank you for your attention.
Hey, thank you very much. I don't know if you heard, but there was a lot of applause here in the room.
I did, and I appreciate it.
Our next talk on NAMs and in silico approach